Makecode. And I guess let's start. So, other than maybe some glitches or minor issues, were there any other sort of major issues or questions with the stuff that was in the platformer tutorial? Okay. What about the extra levels bit? Did that kind of make sense what you were doing? So really, how did you get to another level? What was the procedure, if you will? Sort of two parts. Yeah. Okay, so I guess three parts because what triggers it? Okay, so the trigger was overlapping a particular space or block or whatever. Right. Yeah, so you got to change the tile map to the new tile map for whatever new level. And then also the player's coordinates on the old tile map are not necessarily what you want the player's coordinates to be on the new tile map. So you have to change the player's coordinates to whatever on the new tile map. And uh, which obviously is going to depend. And then off you go, right? The game would resume like normal. Now, if you wanted to do something like just thinking about like Mario, where you get to the end of the level and what happens, like original Mario. Yeah, there's like the flag or walking into the castle or, something along those lines, right? So that's still part of the same tile map. What you would just do is temporarily disable control of the player and sort of manually code them moving towards the castle or towards the right end of the level or whatever. And then you would use that to trigger that it's time to move to the next um, tile map or screen, because you could, for example, like in original Mario, right? Like the screen goes black and then it says like world something dash something, and then after a few seconds you actually see the tile map. So you could do something like that, right? Like where temporarily you don't have a tile map, or you have a tile map that's just black and that has text on it of whatever, So you could make that a background, and then the tile map would just not be there. So yeah, okay. So the other stuff like the jumping, uh, did we? What was sort of the issue did with the double jump? Right, you could spam the jump button, as you guys probably discovered, right? And so we sort of talked about a workaround to that. What was sort of the idea? So let's get back to the, all right, what was it? Save the forest? No, not save the forest. What am I doing? Um, what was it called? Oh, and the skill maps. There we go. Jungle Monkey. Okay. Um, yeah. So okay. So what the double jump thing, right? Is so we've got more levels. Animate the monkey. Uh, make your dynamite just a little bit dangerous, and so on. Okay. So in terms of the movement, so let's go through this one, which was the jumping part. I thought I had already added that, but maybe I didn't save it. Okay, um, so we've got the gravity jump, right? Oh yeah, we did finish it. I just never hit next. Okay, um, because that was right where we sort of finished. All right, so let me go back in here, right? And what was the sort of issue? Well, okay, so the gravity jump. That okay. That I see why they added that. Uh, So notice that I can't spam the up button here with the gravity jump. So the gravity jump function, oops, that's not what I wanted. Oops. The gravity jump function builds in basically that you can't spam it. Okay, so but what was the downside to the gravity jump? Yeah, exactly. There's no way to alter how powerful the jump is or not, right? Which, I mean, I think we would agree that the jump within the scale of the level is probably about right. Okay, but how do we know that we don't want to have like a power up that doubles how much you can jump or whatever, right? Um, and there's no way under the game menu or anything like that, I don't see any way to change what the gravity of gravity jump is, which, okay, c'est la vie. Okay, so the only way that we could control the gravity jump would be to change the acceleration in the y direction to, what did we just try, 500? And actually, it should be minus 500 because we want it to go up, not down, right? Okay, so let's try that out. Oops, that's not what I wanted. What did I want? I wanted velocity, not acceleration, because what I just did was basically make the thing. Okay, I think we'd agree that that's a little bit too much. Okay, so let me try negative 200. That looks pretty similar to the other jump, but now we can spam it, right, is the problem. Okay, so a couple things we could do would be either to try and use like a timer so that you can only hit that button like once every second or two or something like that. That might be a little bit ham-fisted. The other thing we'd want to be able to do, and we may not have the block for this, which is, so let me actually go through the end of this. Let me take this and save it. Oops, where was I? Yeah, Sam. So this is, let me go back to, let's see, save to my projects. This is what I wanted to do. So the gravity jump didn't have any parameters, or at least not within the tutorial. So let's kind of get out of the tutorial mode and see if we do have a little bit more control over that. So yeah, because like the gravity jump here, you notice there's not like a little, there's nowhere where we can put a parameter for it, right? And so that's sort of the problem, is how could we change the parameter? And let's see if there's anything in here that we can, oops. So we've got the control over velocity, acceleration, friction, okay. But there's no variable attached to the gravity jump. That's annoying. Let's actually see. So sometimes you can, let's see if we go into Python view for this, if there's, yeah, see, sprites.gravity jump. We'd have to like find the source code for Makecode to like see under the hood how it was doing it. Because if it were, what we could do is like modify the gravity jump function to accept a parameter, a number, and then we could do it. But the way they've coded the gravity jump function does not accept a parameter. Okay, so now for something like Mario, I think this basically works. Um, you know, because in Mario, I don't think you can jump any more than a set amount, and that's it, right? Oh, right. Okay. Yeah, now the wall jump would have to be like we'd have to do some sort of like collision detection to enable whether or not you could. It's not simply going to get triggered on if up button kind of thing. And I suppose there is also in a few of the levels there's like a springy thing that you can jump on that'll like shoot you up really far in the air. Now that we can handle with just setting your acceleration when you intersect one of those things because it's not really you jumping, it's the thing changing your acceleration. Um, yeah, so, okay, Sam. Uh, where? Okay, so, yes, okay. Oh, there it is. Yeah, okay, my sprite AY is 500. That sets the acceleration. So let's actually go back to the block version because, um, yes, okay, so why don't we try this? Why don't we get rid of that and set the acceleration to 100 and see if that changes the gravity jump. Because if it's just accessing what the sprite's acceleration is, that makes sense actually. Um, um, yeah, that makes sense because look now, I've got acceleration 100, which is lower, right? So I've cut the acceleration, the gravity basically by a factor of 5, and we jump a lot higher. Okay, so that actually does it. Um, yes. So what this means is that the gravity jump. Okay, so you are sort of passing it a parameter, but indirectly, because what you're telling it is which object to gravity jump. Okay, well, if my sprite is a sprite that has an acceleration, it's using that acceleration when it computes everything for the gravity or for the jumping. Okay. So if we wanted to have like a power up that made you jump higher, then what we could do is just temporarily turn off the acceleration. Okay. Now, that I think that's still not quite the way I would want to do it because um, jumping higher is different than changing the acceleration. Okay, and what I mean by that is like let's say that I have like a Nerf gun or something and I fire it straight up into the air, right? Um Gravity is still gravity even if I double the muzzle velocity of my Nerf gun so that the dart comes out twice as fast, right? It comes out twice as fast and therefore is going to go higher, okay? But once it hits the top of its arc, the the falling pattern is going to be the same for at least a little bit as it would be if it went up at half the velocity, right? So you guys see the difference in the physics here? Yeah, but if I also change the acceleration, how high it goes. So like if I let's say I keep the launch velocity constant, but I have two versions. Version A that has normal acceleration and version B that has half acceleration. Which one's going to go higher? The half acceleration one. Okay, and why? Because what slows it down to zero velocity and brings it back down? Gravity, which is acceleration, right? And so if the acceleration is halved, the thing tugging against it, if you will, is tugging against it slower, and so it will take longer in time for its velocity to hit zero, which is longer that it's going up. Okay, so so this sort of works, but maybe not quite because you'll notice that there's no thing here that says once you're in the air, then set the gravity back to whatever it was, right? Okay, so I still think like the best way would be to make this change your velocity by a certain amount, control that amount, and then leave acceleration as a constant. But if I change this from make my sprite gravity jump to a change the velocity of the sprite, what's the problem? What was the problem if I replaced this with this? Yeah, I could spam it. So the gravity jump function, however it's built on the inside, must have some sort of ability to detect whether or not we're actually on the ground or not. Okay. Now, actually, what we could do is this. I just sort of thought about it. Because, so look what we've got for, we also can access what the MySprite velocity and acceleration is. How do I know if I'm in the air? Well, but it could also be less than 0 if I'm coming back down. Okay. Yeah. Okay. Now, this does get us this very, very, very slight danger, because what happens if you manage to hit the button at the exact instant in time that you're at the top of the, right. Okay. If you were clever and able to do that, then you could. Okay. So what we could do is we could actually use some logic here, and we could say if my sprites, and I need also an equal or not equal here. Okay, so if my sprite's velocity is different from 0, okay, that means that I'm currently in the air. Okay, I'm moving in the y direction. Okay, and then if so, I could set my why do we have an error here? Oh, I got the wrong. Yeah, I got the wrong one. Okay, so I got the I needed this one. So what happened there was I was using the equality checker for strings rather than the equality checker for numbers. And of course, numbers and strings are different objects. You can't mix them. Okay, so that's what I wanted. All right, so let's test this out and see what happens. Okay, so my acceleration, let me set it back to 500, which is what it was originally. Okay, so now if I hit the up button, oh, sorry, it should be negative 200, yes. And it should be equal to 0, not equal to 0. Because not equal to 0 says that we're either going up or coming down. Okay, so I'm trying to mash it. You can see the thing is indicating. So that actually works pretty good. Hmm? Okay, so let me come look at it. Yeah, it can happen. If velocity y, oh, equals 0, not equal. Yeah, that was my bad. So because not equaling 0 tells us that we're either going up or coming down. Equaling 0 means that we're, strictly speaking, like we've got that edge case, which is when is the velocity 0? If we're on top of a block and we're not going up or down, that makes sense, right? But if we jump, what's our velocity when we hit just the tippy peak of our jump? It's 0 for an instant in time. Okay, so if and maybe like if we practiced at this, you guys could kind of get where you could time it and nail it so that it right when it hits 0. Now the odds of that happening are pretty low, but theoretically you could. right? Okay. All right. Well, so that actually works pretty well, I think. And the benefit then is um, that velocity number we can tune to be whatever we want. Okay. And if we wanted to have a power up that allowed you to jump higher, then how might we implement something like that? Okay, so that would be something that would trigger it. Okay, um, is on overlap. You get this thing, and then maybe we need some sort of variable to keep track of whether or not you have that overlap. Okay, and you could say, okay, when you get that power up, set the set some we'd have to make a variable called like jump velocity, and then where we have the minus 200, replace it with that variable. And then when you touch the power up, you change the velocity or the jump velocity to, oh, I don't know, minus 400 or something. I'm just making up a number here. And then at some point, what else would you want? Do you want to be able to jump, special jump all the time? Yeah, some sort of timer or some sort of condition on which you lose the ability to power jump, right? Um, and so, which could be a timer. It certainly doesn't have to be. Just thinking about, well, let's see, maybe what game would you have something like this in? Um, what about, well, I'm thinking of Breath of the Wild, but that's sort of obviously a newfangled game. Um, I have, but I've never played it. Um, Super Meat Boy. Yeah, that seems like a pretty typical Wabash game. Yeah. Although, on the subject, maybe I should shut the door for this part. Has anybody ever seen or played genital jousting? Look it up real quick. It's pretty, or maybe don't, right? Uh, yeah. Oh, is it on sale for the, of course, for Lunar New Year? Yeah. Please, nobody make that their game, uh, because, yeah, yeah, exactly. We'll be inviting the whole campus to come play your games, and if they're that, then I'll probably get fired. And I even have tenure, so it's hard to fire me. Um, yeah. Okay. So, yeah, we need some sort of timer. But what I was thinking of in like Zelda is um, there are some of these like more RPG style games where you gain abilities over time, right? Where like maybe at some point in the game you get the ability to double jump, okay, or something along those lines, where you want it to be permanent once you get the ability. And that might be relevant to your game design, right? So there might be a thing where having the higher jump ability makes sense for it to be permanent for the player. Actually, the example you mentioned earlier, which is it the case that you jump higher if you're Big Mario versus Little Mario? I don't remember. Okay. Well, let's just assume that it is, right? And that you were making sort of a Mario style thing where you could be Big Mario or Little Mario. Well, then you would just make it so we'd have to maybe add a condition here. If the velocity is non-zero and we're Big Mario, then make it one value. Otherwise, if it's Little Mario, make it the other value, right? Does that make sense? And then presumably you could actually have multiple cases for that because what about like if you um, I don't think this is the case in Mario, but if you've got the star power up, maybe you want to be able to you jump extra high in that case or something, right? Or you've got the Tanuki suit in Mario 3 or one of the other Mario games. Or presumably, actually, you could do this. Has anybody played Mario 2? It's a weird one. Yes. Yeah, the eggs and the doors and the weird birds and stuff, and it's all like well, okay, and the fair point, because it actually was a different game that they reskinned with Mario stuff and then sold it as Mario 2, um, which is kind of hilarious. So they took basically a game that was only ever released in the Japanese market and then doctored it up and made it Mario themed. But in particular, what was unique about that game is that on a per level basis, you could actually choose which of the four characters you played. Um, and Luigi could jump a lot higher than Mario, but also had like, so each character had different abilities. Um, and Peach or could, like, she was wearing a dress, so when she was falling, like the dress would sort of like almost act like a miniature parachute and slow the rate at which she fell. And then Toad, like, so they each had different abilities, but the Luigi one in particular could jump a lot higher than the other characters. And on certain the levels were designed in such a way that, like, if you were Luigi, you might be able to get to a coin or a special access door or something that you wouldn't be able to unless you were Mario, or it'd be much harder to get up there or something, right? So, which made from a replayability standpoint, it made the game a little bit more interesting, because if you kept track of, oh, in level 7 there's this place where it'd be really handy to be Luigi to get there, then maybe you could try playing it that way instead. Um, yeah. Okay. Um, okay. So that kind of makes sense here. Um, the block thing. The other thing we could do is some sort of overlap check. The problem that and the reason I would maybe not want to go that direction is because if you've got a really complex tile map with lots of different things that you could be standing on top of, you'd have to have a case for each one, which would kind of suck, right? Because it'd just be a lot of logic to deal with. So this is probably a bit cleaner. We could actually doctor this up to do a double jump kind of thing. Maybe we can talk about that later or another day. Um, okay, but are we kind of, getting the hang of this? Really isn't rocket science. Um, so what I want to sort of start to do is sort of pull the training wheels off, so to speak. Let's talk about the extra features that you guys were working on. What ideas did you have? What have you implemented, Sam? Oh, okay, okay. Um, and did you put a timer on it or something, or just okay? Okay. So floating like Peach. Any other ideas? Yeah. Okay, okay. So what you could do in terms of spawning, right, is if we go to the sprites, right, you can set its a particular sprite's position to X, Y, something, but that little circular spot, you could actually plop my sprite X into it, right? So if I took this guy and plopped it in here, then I could actually have it spawn at whatever coordinates, so that the X coordinate was the same as the sprite, and then the Y coordinate you'd want to be somewhat up above it. Yeah, you could like use that value and then add a random number, like say between minus 100 and 100 or something, or maybe not that big, but between minus something and something, so that it would always be kind of around the sprite, and maybe sometimes randomly would be almost right up above it, but there'd be some variation to it. Yeah. Absolutely. Yes. Okay. And in fact, so let's sort of think about how you would do that. Okay. If you wanted a projectile, right? So in the space shooter, how did we handle the projectile? We spawned it, right? And when we spawned it, what did we have to say?
You mean like the one that we were making?
Yes.
Okay.
Yeah. So our shooting to shoot against the enemies.
We just set like the velocity of
To something, right? Okay. So let's think about this from a physics perspective, right? If I want to shoot something, okay, and let me just for the sake of simplicity write this instant. In our space shooter, were our pew pews subject to any form of acceleration? No. Okay. Now that's obviously not realistic if you're shooting like bullets or something. Like if I fire a Nerf gun, the Nerf bullet is subject to the exact same gravity that everything else is. Okay. Now let's temporarily assume that the Nerf bullet has no gravity attached to it. Okay. So if I wanted to shoot Adam with my Nerf gun, okay, how would I want to aim? I would aim directly at him. Now, if the bullet was subject to gravity, then how would I want to aim? Very, very slightly up. Okay. And if I was really far away, I'd have to aim a lot up so that it would arc and hit him. Okay. Whereas if I'm, within the room and it's shooting relatively fast, I can sort of neglect that because if I hit him here versus here, right? Like that, do I really care? I mean, I'm not a marksman with Nerf weapons, right? But if I'm a military sniper or something, then we do have to worry about those sorts of things. Okay, so if I wanted to spawn a projectile at a particular sprite going towards another sprite, what kind of stuff do I have to think about in the process? Well, I need to know where both sprites are because, like, how do I know which direction Adam is for me? Well, I mean, I have eyes, obviously, but like in a math sense, I would need to know his coordinates and my coordinates. Okay, does that make sense? Okay, I would also need to know the velocity, or okay, sometimes we call this muzzle velocity. Basically, how fast does the projectile fire out of the Nerf gun? Okay, and that number is the same no matter which way I'm pointing the thing, right? And but the reason I need to know that is because that is a directionless quantity, and essentially we're going to have to do some physics. Okay, so let me come up over here to the chalkboard and let's just kind of write out how this is look. Um, this is where it's handy to have a math professor, right, teaching computer science, is because, well, I guess as I'm about to do a bunch of physics, right? So, uh, yeah, but that's okay. This is Goodrich Hall. We like all three of them, right? And then I find a piece of chalk that is not a super teeny nub. Um, this will work. Okay, so if I have my coordinates here, um, so let me call this x naught, y naught, and I have the target's coordinates, which are there, okay? I would want to shoot it in this direction, right? Which means that I need to set its velocity in both directions to a specific number, okay? And so what I need to do is kind of figure out, I mean, I guess there's a couple ways we could do this, but when I set the velocity, so let's say, for example, that well, let me actually just, for the sake of convenience, let me just actually put this above. It makes the picture a little easier to draw. Right? If I want to set its velocity so that it goes in the correct direction, what I have to do is set its x velocity and its y velocity to the appropriate numbers. Okay, now, so think of that we're in a 2D world, and the 2D world is running this way, right? So my position is X something, Y something, and so's Adam's, right? So if our Y positions are the exact same, then that would be the case where I'm here, he's here. I would want to shoot directly horizontally, okay? And if I were above or below him, then I would want to shoot direct vertically, right? But of course, that basically never happens. So if I'm at some sort of angle like this to him, how do I determine the velocity of the x component and the y component?
You have to create a function basically of the hypotenuse.
Right. Okay. So there's some sort of angle there, right? And the velocity I would need um, would be this. Okay, V naught here is the muzzle velocity, so that's basically the speed at which the thing comes out of the barrel of the weapon. Okay, and then sine and cosine, right? Now let's think about the situation if I'm directly, like we're at the same y level but different x levels. That would be the case where theta is 0. Well, what's sine of 0? 0. What's cosine of 0? 1. Okay, so that would mean my horizontal velocity would be exactly the muzzle velocity, and my vertical velocity would be 0. I'm aiming horizontally at him. Okay, now here's the problem though. How do I determine what theta is? Right, I've drawn it in the picture, but how do I compute what that quantity is? Yeah, I got to do some tangent stuff, right? So what is the tangent of this angle? Um, yes, but um, okay, it's not Vy over Vx actually. Or no, it is. Yeah, because that'd be tangent of theta, right? If you because the V naughts would cancel. So that's true, but I can't use Vy and Vx to compute the angle when Vy and Vx are determined based on the angle, right? That's sort of a circular definition. So while that's true, it doesn't help me. Okay, so I need another way to compute the tangent of theta. Almost. What's this distance here? It's the difference of the y coordinates, right? And similarly, what's the base of this triangle? It's that. Okay, so then what would the tangent be? Yeah, the ratio of those two things. Okay, and if I wanted to know what theta is, then what? Yeah, I did arctangent. Okay, so theta would be arctangent of that. Okay. Um, Now, sometimes, and just so we're all clear, arctangent and the function that's written like that are the same thing. Okay. I personally prefer to write arctangent. Why? So there's a reason, and it's not just historical, why I like to say arctangent rather than tan to the negative 1. Any ideas as to why? Yeah, exactly. That's why. Because in every other or most other circumstances, if I put something to the negative 1 power, what does that mean? It means 1 over that quantity. Okay. But not here, right? And so in order to avoid that ambiguity, I just use arctan because then there's no possible way you could mix it up. So that's just this is one of those things about mathematical notation. You guys probably have realized there are inconsistencies in the way that we write things in math. Is that irritating? Sure. Um, why does that happen? Why does math have inconsistencies in notation? Well, there's that, but also who does math? People, right? And people are inconsistent critters. Okay, maybe another way to think of it is, which is perhaps a bit more liberal artsy, right? What other languages besides English have you guys studied? Okay, most of you probably Spanish. Okay, fine. Any languages other than Spanish? German? Huh? Really? You studied Tagalog? How did that happen? That's really uncommon. With Dr. Rogers on. Okay, that's interesting. Yeah. Okay, that was not what I was expecting to hear this morning, but that's okay. All right, can anybody one up Tagalog? Did anybody do ASL in high school, sign language? I had an advisee once that did. Like instead of Spanish, he was able to do like 3 or 4 years of ASL and loved it. Absolutely loved it. Okay, so anyway, you've all studied a lot of different languages. So let's just take Spanish as our example since it's a pretty common one. Um, so, how do you conjugate verbs in Spanish? Yeah, there's different endings. Okay, and for the most part, do they all work the same way? Except there's all these irregular verbs, right? That don't obey the rules. Okay, the same way that sort of the, if you have the verb, and what verbs tend to be the irregular ones? Huh? Oh, well, okay, so that's a particular example, but what are the meanings of the things that typically are irregular? They're pretty common expression verbs. Verbs of being, verbs of doing, verbs of existence, seeing, hearing, going, right? The kind of very most basic things that any language needs for people to communicate. Is there is the verb um, to purchase a plane ticket or to purchase, is that irregular? No. Okay, that's a more regular verb, but it's also not like, you need to have the concept of commerce before you can have that verb. Whereas being is a concept that like just, yeah, right. That's sort of a much primitive, more basic concept. Okay, so it's the case that probably in most languages, those sorts of basic verbs often are the ones that are irregular. Okay, and part of that is because they're more ancient, if you will, right? They go back a long way, right? And so let's take the verb or verbs, I guess, to be in Spanish. What are they? You've got ser and a star. Okay, so the fact that there's even two of them is interesting. Why? Why are there two of them?
How you feeling, where you are, always use the verb star. And then say basically everything else.
Okay, well that works, right? Yeah, but they have different uses, right? And then if you were to trace back the lineage of both of those words to sort of see why is it that one is used in certain cases and others in others, it's going to go back to, well, now we have to look at Latin and what is the verb to be in Latin and how does it work there? And then, of course, Spanish, like how did Spanish come into existence? Yeah, it's a Romance language, right? So Latin is the base, along with whatever vernacular kind of street Latin people were speaking back in the day. Okay, Roman Empire dissolves, but what else do you have a lot of in Spanish? Right? It's not as if Spain is just, or what became Spain is just like this island in the middle of nowhere with no contact with other people speaking other languages, right? So there's Arabic influences even in Spanish from the Moors, and you know, so the language evolves over time, and it still has those irregularities. Well, math is no different. It's a language, the way we express it, right? So we shouldn't be too shocked when there's sort of some inconsistencies there where most of the time a thing means one thing, but in certain cases it means another. That's just human language, right? So, get over it, I guess. Just the way it is. Okay, so anyway, that was our hashtag liberal arts college moment for the day. Okay, so arctangent. Now, everything we just did on the chalkboard, all that's all well and good, but what about if we don't have those functions built in here? We're kind of SOL. So let's look at the math library and see what we've got at our disposal. Okay, we do have here this function thing, for example, and you'll notice that what do we got? We got sine, cosine, tangent. Okay, that's good. We've got square roots. That's also nice. And then we've got this thing called atan 2. Has anybody ever heard of arctangent 2 instead of arctangent? Yeah, it does. Okay, so it's basically arctangent. Okay. But it fixes a problem that arctangent has. Namely, what would happen if I was directly above Adam? Well, we would know that my velocity that I shoot the thing would need to be either straight up or straight down, depending on if I'm, well, straight down in the case that I'm above him, right? But in terms of the formula that we just crunched over there, what's the problem? Keep going.
Have you defined the quadrant you're in?
Okay, so there's that issue. Although that's sort of a relative quantity because the angle depends on both of us, right? But just look at the arctangent formula I wrote. What's the problem if I'm either directly above or directly below my target? Yeah, the denominator is going to be 0. x1 and x0, the x positions of the two objects are the same number. Well, I don't know about you guys, but what's division by 0? It's bad, okay? You shouldn't divide by 0. Okay, so AT2 is a function that basically deals with this. Okay, so let's look at how it works. And what you give it is not one quantity, but two quantities. You give it the, and we'll have to check the order here. Basically, rather than giving it the fraction, we give it separately the numerator and the denominator. Okay, and then the way it's coded is it's actually a piecewise function. And so it says, oh, well, if one of these quantities is 0, then that's the case of a vertical angle, and then I'm either going to return 90 or negative 90 based on the sign of the other quantity, right? So it basically sorts out all those problems that we have. Okay, now what I don't remember is whether or not you put the y one first or the x one first. So let's actually just look it up real quick. So this function, by the way, exists in Mathematica. And I'm imagining that they have the same syntax for it or similar. Yeah, okay. So it's probably you give the x first and then y. Okay. And of course we could test this because we could just put in numbers here, known quantities like 0 and 1 and 1 and 0 and see if we get the right answers. Okay. Okay. So anyway, we have to do some physics, right? If you wanted to do projectiles that are going straight at a particular target. Okay. Now, here's where it gets either more fun or less fun, depending on how you want to look at it. What happens if I want to shoot Adam and Adam is moving? If I used this setup, what would be the case if Adam is moving?
The moment you shoot, it would be.
I would be.
Okay, so at the moment you shoot, that's where you would be aiming.
Yeah, I would aim at where he is at the instant that I'm firing with the formulas that we've written down. Now, am I going to hit him? Possibly not. It's going to depend on which direction he's moving. Okay. So if we wanted to doctor this up to make it so that I could aim and hit him while he's moving, right? If he's moving towards the door, right? What would I need to do? I need to lead him a little bit, right? And so now, how do I know what his velocity is? Could I access that? Yes, right? I can access his velocity just as well as I could access his position, okay? But our math would get more complicated, I guess, is the moral of the story. Which, of course, yay, right? You guys don't like more complicated math? No? Yeah, well, so okay, so yeah, that was, sorry, a long digression about physics, but um, if we wanted to make a game like, well, did anybody ever play, um, oh, what was it called? It's like a turn-based game, and you're like a little tank or something, and you're trying to shoot other players.
I know what you're talking about.
Well, and there's a lot of games that have sort of used this mechanic. I remember a basic program in DOS called, I think it was Gorillas, and it was basically you were a gorilla and you were throwing explosive bananas at other gorillas. And basically what you had to do is you had to decide what angle and velocity you were throwing it at, and then it would, model the physics. And um, now everybody was fixed in that case. But if we wanted to make a game like that, that's going to be a very physics heavy kind of simulation, which just means, of course, doing lots of exciting math. Okay. Um, Now, in the case of like Mario Brothers, is there really anything that does much shooting? I mean, there's a few things. You might get the fire flower, okay, but do you really have aim control with the fire? No, it's basically just, is it going left or right, right? And how it shoots from Mario is sort of a fixed quantity. What else? Yeah, the Hammer Brothers, right? Okay, and they're kind of similar, right? It's always thrown the same way, and they just kind of move in such a way as to keep Mario kind of close by. Um, there's, I want to say, aren't there some of the piranha plants that do shoot fire at you? Okay, and actually, those probably use something along these lines. Okay, um, to do it. Okay, although I should point out, like if we think about the original Nintendo, this computation that we've done is all great. Okay, but what does it depend on? It depends on our ability to do floating point, basically to deal with numbers that aren't whole numbers, right? And in particular, we also have to be able to have this arctangent function, right? Now, modern computers, um, which is to say anything from the 90s on, um, have hardware ability to do a lot of that kind of computation. But if we take a computer from the 80s, well, like the Nintendo or the Commodore that's sitting on the desk, they did not have the hardware ability to do anything involving non-integer numbers. And in fact, there was no trigonometry either. Okay, so if you wanted to do stuff that involved trigonometry, you essentially had to write a program that could do all of that stuff, right down to the arctans business. Um, so yeah, so we'd have to doctor this up basically if we wanted to do it on old school hardware. Now, in Makecode, do we really have to worry about it? No, right? We're on modern computers, even though they're kind of, the graphics and stuff is designed to be retro. You still have all of the resources of a modern machine. Um, but the guys in my other class that are actually programming on live old hardware, right? When we get to the point of them trying to make games, they're hosed in the sense that they don't have a lot of the kind of luxuries, if you will, of modern computing, which just makes it even more fun. Okay, um, yeah. In fact, this machine and the Nintendo, can only, at a single instant in time, can only work with two numbers that are between 0 and 255, or negative 128 to 127, depending on which way you think of it. But basically, that's it. So then think about the Nintendo, and think about how complex Mario is. And it's all working on a machine that's that simple under the hood. It's kind of amazing. Yeah? Yeah. So, yeah, you had to be really clever back in the day to program some of this stuff. Okay, so shooting, where were we? We were talking about other things that you guys could add. What other ideas? Well, don't jump up all at once. Yeah,
I kind of did want to make the bomb throwable. Instead of just placing it down.
but you could,
Yeah.
right? Yeah. So the dynamite stick, right, or whatever that you place, you could make something where you could throw it instead. Yeah.
How would you make it like art? And like make
Yeah. Okay.
throwing it in line?
So how you would make it arc? Two things. Well, you let Makecode do it, right? In order to set something into motion, you need to specify where does it start, what's its velocity, okay? But the arc happens because of gravity, right? So what you would have to do is when you create the projectile, you would have to give it, that would get it shooting diagonally, but you would also have to attach to it an acceleration constant. Okay, which for the purposes of the game should be probably the same as everything else's acceleration constant, because it would be a little weird if the player's acceleration was different than everything else in the game, right?
So this is set my sprite like AY, so acceleration of Y. So
To
that's what we would set it at.
Yeah, but instead of my sprite, it'd be whatever the name of the other object is. Yeah, exactly. Um, and then set that number to whatever it needs to be, the acceleration. But you'd also set the velocities to something comma something in order to shoot, diagonally,
So
right?
come down.
Yeah. So if you did that, right? So like, let's say you made your initial velocities the same, or actually, let's say you made your initial y or x velocity 100, y velocity minus 100. That would be shooting at a 45-degree angle from the horizontal, right? Um, and which, depending on what you're doing, that might be fine. If you wanted to adjust that angle, well, then you have to do the sort of trig that we were doing over there, right? 45, 30, and 60 degrees are pretty easy to do the computations, right? You don't need trig to do them. You can just use basic, right triangle geometry from like 8th grade or something. But if you want any angle that's sort of funky, not one of the special ones, then you have to hit the math seriously hard. So, yeah. Yeah, so 0, 30, 45, 60, and 90 are the easy angles. You can get some other angles if you know a little bit more trig without having to technically do trig, like, um, if you know 30 degrees, you can get 15 using some wizardry. But if you want 17.8 degrees, well, you just got to have a trig function. There's just no way around it. So, I mean, unless you're willing to do an approximation, which might be good enough, but then to do that approximation, you still have to know more math, right? So, what's the moral of the story, guys? Math. Math is the moral of the story. No. Or actually, I guess it'd be kind of like, you guys ever seen Futurama? Have you seen the episode where the Dr. Farnsworth invents the brain switcher device? Oh, let me show you guys this because it's hilarious. All right, first off, let me switch the audio output to so that it comes out the speakers instead of the AirPods. Um, I guess we want to go out that. Yeah, that's what we want to go out. Okay, so the audio should come out the speakers. Okay. All right, I'll figure out why you're not getting audio here in a second. After we get through the stupid ads. Okay, so I was able to hear something. Was it just really soft? Okay, so I just need to up the volume over here on the control panel.
Wasn't Futurama made by like a bunch of actually like, really smart people?
Oh yeah, same thing with The Simpsons.
So they're like the smartest animation cast.
Pretty much. Okay, so let's. Okay, so I just need to up my output audio. I don't think I could up it much more. Well, you know what? Let me just put it on my computer speakers because they're loud enough that you guys should be able to hear it.
Mathematics, you need to watch Futurama. In the prison.
Oh, I don't want your stupid thing. Here we go.
Now then, Amy, we'll simply switch bodies, and then we'll. No, I'd be back in my body, but then you and Bender would be switched. And the Amy and Bender bodies can't trade minds again since they just did.
Oh no! Is it possible to get everyone back to normal using 4 or more bodies?
I'm not sure. I'm afraid we need to use math.
Yeah. So anyway, so they need to use math, and so what do? Who do they call immediately in the episode? They get the Harlem Globetrotters, of course, right? Right. And so they call them in, and they've got a bunch of chalkboards, and they're able to figure it out. And actually, we use this thing in abstract algebra to explain transpositions in a certain thing, and there's a really good theorem that sort of comes out of the Futurama, the brain switching episode. So it's like it's money for us mathematicians. Yeah. So anyway, and they actually consulted with mathematicians when uh, developing the script and all of that to make it all work out. So, okay, well, so this was fun, and I guess I'll see you guys on Tuesday. So I'll post something for you guys to do on Canvas to start thinking about. We'll start making our own stuff rather than doing tutorials. I think we're at that point. Okay, see ya.